Hello, my name is Daniel. I'm joined by Dennis and Delanne, and we're part of Project TBH, which is the Tactical Biometric Handheld Device. We are a balanced team, which also consists of Sam, Joshua, Brandon, Xenia, and Hassam. And we came together to provide a mobile device that aids in the collection and matching of biometric data for people of interest. And we based our project requirements mainly on the priorities of TSA and Homeland Security, as well as NATO's Support and Procurement Agency. So this would be most useful to them in an airport where they could scan travelers. Now, the device itself would need a 6-hour battery life. It would need to capture the user's thumbprints, both irises, and perform a facial scan. We'd also need a secure cloud storage system to hold the sensitive information and a one-to-one matching algorithm that will match the user to any people of interest. And we've been operating with UN sustainability goals in mind, and we believe that the implications of our device will have a net positive impact on the world.
So our main competitors consist of Major eGate by IDEMIA, BioSled by Northrop Grumman, and Biometric Terminal by ECAM. Each of these solutions seem to have various pitfalls, with the main one being their inability to meet the technical, physical, or political requirements that are proposed by many government bodies. This is our hardware architecture block diagram. As you can see, we're utilizing the Yo-Yo microcontroller to handle communication between our sensors and the Android device. As for the power implementation, we're using an 18650 LiPo cell, which is getting charged by the TP4056 LiPo charger, and whose voltage is boosted to 5 volts to power the Yo-Yo board and the serial camera. The communication between the sensors and the Yo-Yo board is handled through the UART protocol, while communications between the Yo-Yo board and the Android device are handled through the USB protocol. We went through other various design changes, but ultimately decided on this one due to its compatibility with available sensors, its low power consumption, and the ability for the Yo-Yo board to charge the Android phone while in use.
Our software architecture looks as follows. For the onboard application, the Android app gathers the information from the Yo-Yo controller, and since we are dealing with large and sensitive biometric information, the app sends the AES encrypted data to an AWS cloud computing service. From there, we either access machine learning algorithms for matching purposes or access our AWS storage system for the biometric information through a database reference. For an introductory look into our Android application, a portion of our classification flow is presented here. A TSA agent would begin in the login page where they would input their credentials. Once authenticated, their options are presented for what they would like to do next. In this case, the agent starts the scan for the fingerprint and allows the user to use the device to scan their finger on the fingerprint sensor. The data then flows through the channels outlined from before as the agent continues with their operation. From there, we move on to our project roadmap. Outlined in green is what we have completed, and in red is what we still must be doing in the coming months. Currently, we have set up all the framework for the beginning communication, and our next milestone will involve establishing data transmission between the Yo-Yo board and the Android device, and communication between our different cloud services. With this, we are one step closer to a finished product. Thank you all for listening. Are there any questions?